The end of materialist science. The information. An algorithm is a scheme for the manipulation of symbols, a garden of branching forks, but to say this is only to say what an algorithm does. Symbols do more than suffer themselves to be hustled around. They are there to offer their reflections of the world. They are instruments that convey information. The most general of fungible commodities, information has become something shipped, organized, displayed, routed, stored, held, manipulated, disbursed, bought, sold, and exchanged. It is, I think, the first entirely abstract object to have become an item of trade, rather as if one of the Platonic forms were to become the subject of a public offering. The superbly reptilian Richard Dawkins has written of life as a river of information, one proceeding out of Eden, almost as if a digital flood had evacuated itself at its source. Somewhere in the wheat-stabbed fields of the American Midwest, a physicist has argued for a vision of reincarnation in which human beings may look forward to a resumption of their activities after death on the basis of simulation within a gigantic computer. Sexual pleasures are said to be unusually keen in the digital hereafter. The American mathematician Claude Shannon gave the concept of information its modern form, endowing an old, a familiar idea with an unyielding but perspicacious mathematical structure. The date is 1948. His definition is one of the cornerstones in the arch of modern thought. Information, Shannon realized, is a property resident in symbols, his theory thus confined from the start by the artifice of words. What Shannon required was a way of incorporating information into the noble category of continuous properties that, like mass or distance, can be represented by real numbers. Philosophers have from time immemorial talked of symbols and signs, their theories turning in an endless circle. Shannon regarded their domain with a mathematician's cold and cunning eye. He saw that symbols function in a human universe where things in themselves are glimpsed through a hot haze of confusion and doubt. Whatever else a message may do, its most important function is to relieve uncertainty, rejoice. We conquer, making clear that one side has lost, the other won, the contest finally a matter of fact. It is by means of this superb insight that Shannon was able to coordinate in a limpid circle what symbols do, the accordion of human emotions wheezing in at doubt and expanding outward at certainty, and the classical concepts of the theory of probability. A simple binary symbol, its existence suspended between two equally likely states, on or off, 0 or 1, yes or no, holds latent the promise of resolving an initial state of uncertainty by half. The symbol's information, measured in bits, is thus 1/2. Simple, no? And so very elegant. The promotion of information from an informal concept to the mathematical big time has provided another benefit, and that is to bring complexity itself into the larger community of properties that are fundamental because they are measurable. The essential idea is due, ecumenically, to the great Russian mathematician Andrei Kolmogorov and to Gregory Chaitin, an American student at City College in New York at the time of his discovery, the spirit of Emil Post no doubt acting ectoplasmically. The cynosure of their concerns lay with strings of symbols. Lines of computer code, and so inevitably algorithms, are the obvious examples, but descending gravely down a wide flight of stairs, their black hair swept up and clasped together by diamond brooches, Anna Karenina and Madame Bovary in the end reduce themselves to strings of symbols, the ravishing women vanishing into the words, and hence the symbols, that describe them. Adieu, mesdames. In such settings, Kolmogorov and Chaitin argued, complexity is allied to compressibility and then to length, a simple counting concept. Certain strings of symbols may be expressed, and expressed completely, by strings that are shorter than they have some give. A string of 10 H's, H, 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 is an example. It may be replaced by the command, given to a computer, say, to print the letter H 10 times. Strings that have little or no give are what they are. No scheme for their compression is available. The obvious example is a random string, H, T, T, H, H, T, H, 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 T, say, which I have generated by flipping a coin 10 times. Kolmogorov and Chaitin identified the complexity of a string with the length of the shortest computer command capable of generating that string. This returns the discussion to the idea of information. It functions in this discussion, and everywhere else, as a massive gravitational object, exerting enormous influence on every other object in its conceptual field. The definition of algorithmic complexity gives the appearance of turning the discussion in a circle, the complexity of things explained by an appeal to intelligence and intelligence explained, or at least exhibited, by an appeal to a community of concepts, algorithms, symbols, information upon which a definition of complexity has been impressed. In fact, I am not so much moving aimlessly in a circle as descending slowly in a spiral, explaining the complexity of things by an appeal to the complexity of strings. Explanation is, perhaps, the dramatically inflated word. Nothing has been explained by what has just been concluded. The alliance between complexity and intelligence that Paley saw through a dark glass remains in place, but the descending spiral has done only what descending spirals can do, and that is to convey a question downward.